Hi, we're talking about the first part of 4.1 today. So let's go ahead and dive right in. So we're going to start talking with, about right triangles. And here I have an example of a right triangle. You notice this is the right angle, and there's an angle labeled by that symbol, which is like a 0 with a bar through it, and it's called theta. Okay, like like thin or thick, theta. All right. In this part of trigonometry, once we identify an angle theta, we now have to label the three sides of the triangle. All right, so we know that the longest side of the triangle, which is opposite to the 90-degree angle, is the hypotenuse. That leaves two legs of the triangle which create the 90-degree angle. Of those two, the side that is touching our angle in question is called the adjacent side. Adjacent means touching. And then the third side of the triangle, which is not touching theta, is the opposite side. Right? So that's the first task, is labeling opposite, adjacent, and hypotenuse. All right. When we have that, we can go ahead and find our trig ratios or trig functions. Right? So the first of those functions is the sine, right? And if you see here, that is the sine function. All right, so the sine function, all it is a ratio of the two lengths of a triangle, of the sides of a triangle. So in this case, sine is the ratio between the opposite side and the hypotenuse, right? So opposite side over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So you see, with these three, we've basically paired up all possibilities, for the three sides of the triangle. It's all the three possible pairs. All right. So these are our trig ratios. And an easy way to remember these is SOHCAHTOA. So that says sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Okay, once we have that down, we can define what we call reciprocal functions. Reciprocal functions are when we take these functions, sine, cosine, tangent, and we take each one and we take the reciprocal. So for example, cosecant is hypotenuse over opposite. So you see sine is just flipped over, or we're taking the reciprocal. Secant is the reciprocal of cosine, hypotenuse over adjacent. Cotangent is the reciprocal of tangent, adjacent over opposite, right? So to recap, those three, cosecant, secant, cotangent, are our reciprocal functions. All right, so here's another right triangle, and what we're going to do here, we're given the side lengths of this triangle. We want to find sine of theta, and we want to interpret the meaning. All right, so if theta is here, again, the first thing I do is I label the sides. The longest facing the 90 degree is the hypotenuse. The one touching it is adjacent, and the one not touching it, away from it, is the opposite. Right, so now for sine of theta, we know that's opposite over hypotenuse. So I just look, the opposite side has a length of 1 over the hypotenuse is 2, so it's 1/2. Okay, as far as interpret the meaning, sine is the ratio between the opposite and the hypotenuse. So in this case, if the sine is 1/2, that tells us that the opposite side is always 1/2 of the hypotenuse. All right? All right, next we want to find tangent of theta. Tangent of theta is opposite over adjacent. So that's 1 over √3. And I'm not really sure how much 1 over √3 is. I can't really wrap my head around it. So when I plug it in the calculator, it's 0.5773. So this means that the opposite side in this triangle is always 0.5773 times the adjacent, right? Okay, so let's go ahead and go over to this triangle. We want to find the exact values of the 6 trig functions here. Exact values means no decimals. All right, so sine of theta, we need to use this angle here. Again, I label hypotenuse, opposite, adjacent. So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. Once I've done those, so now these are the exact values, right? They're simplified fractions. Once I've done those, for the reciprocal functions, cosecant, secant, cotangent, I just take those and I just flip them over, take the reciprocals. All right. Now, to round to 4 decimal places, I will just take my calculator, and in my calculator I plug in for the first one 5 divided by 13. That's it. You don't even have to deal with the sign button. All right, and it's 0.3846. The next one, 12 over 13, you get 0.9230769 and so on. You have to round to 4 decimal places, so that's 0.9231. Remember to round properly. And then, you get the idea for the rest. Okay, moving along, for this one, we need sine of angle F and cosine of angle F. So we go to angle F, that's this one. And again, the first thing I want to do is label hypotenuse, opposite, adjacent. So now for sine of F, we're going to do opposite over hypotenuse. But remember, we have to simplify that. So if I divide by 8, it's 4/5. Cosine, adjacent over hypotenuse, divide by 8, 3/5. Tangent, opposite over adjacent, 4/3. And so now for the other ones, all I need to do is take this column, the already simplified versions, and just flip them over, and we would convert to decimals the same way, right? So 4/5 would be 0.8 and so on. All right. Now, let's go to the next type of problem. In this case, we are given a trig function, and then we have to find the values of the remaining ones. So whenever you see this type of question where you're given a trig function, just refer back to this page. This is a 3-step process. The first step is draw a right triangle and label the sides. So here's my right triangle. I need to label the sides and the angle. So what I'm given here is that tangent of A is 5/3. That means my angle is A. So in my triangle, I label one of these acute angles A. It's your choice which one you want to do, but then you have to be consistent. Now I need to label the sides here. Again, hypotenuse, opposite, adjacent. In my tangent, right? Remember, tangent is in SOHCAHTOA, this is TOA, right? Tangent is opposite over adjacent. That means 5 is the opposite side, 3 is the adjacent side. So I label 5 and 3. Okay, that's the first step. The second step is to use the Pythagorean theorem to determine the missing side. So you see here there is a missing side x. So now I'm going to do 5 squared plus 3 squared is equal to x squared. 25 plus 9 is equal to x squared. 34 is x squared. Take a square root, and x is root 34. Okay. Last step is to just do the trig ratios, right? So sine of theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is 5 over 3. Okay, one word in trig, we no longer need to rationalize the denominator, so it's okay to leave that square root in the denominator, all right? And then the reciprocals are root 34 over 5, root 34 over 3, 3/5. Okay, so let's do another example of the same thing. This time I have secant is equal to 3 over 2, right? First step, triangle. Now label angle B, angle B. Secant is hypotenuse over adjacent. So hypotenuse over adjacent. Next, Pythagorean theorem. This is x. So x squared plus 2 squared is equal to 3 squared. X squared plus 9 is equal to, sorry, I went ahead there. X squared plus 4 is equal to 9. Subtract 4. X squared equals 5. Take a square root. X is root 5. So here x is root 5. Okay, that means sine opposite over hypotenuse, cosine adjacent to over hypotenuse, and tangent root 5 over 2. And then for the reciprocal functions, we take the reciprocal, and the reciprocal. All right, so that's it for today. And then you have to do the homework for part 1 of this. All right, have a good day and thank you.